Okay, welcome to section 6.4, Analyzing Graphs of Polynomial Functions. Graphs of polynomial functions. The location principle. Suppose y equals f of x represents a polynomial function and a and b are two numbers such that f of a is less than 0 and f of b is greater than 0. Then the function has at least one real 0 between a and b. For example, determine consecutive integer values of x between which each real 0 of f of x equals 2x to the fourth minus x to the third minus 5 is located. Then draw the graph. So the suggestion here is to make a table of values. You look at the values of f of x to locate the zeros, then use the points to sketch a graph of a function. Okay. So the values that are substituted in here are going to be negative 2, negative 1, 0, 1, and 2. The outputs they give us are 35, negative 2, negative 5, negative 4, and 19. What I'll go ahead and do here to make things a little bit easier is plug in to our graphing calculator the function. So we'll go ahead and type in 2x to the fourth minus x to the third minus 5. So y equals, I hit my y equals button there, 2x to the fourth minus x to the third minus 5. Okay. Now before I graph, I'm actually going to hit zoom and then option 6. Option 6 is a zoom standard view which goes negative 10, positive 10 in the x direction, negative 10, positive 10 in the y direction. So here's my function. This is what looks to be a parabola, but isn't actually a parabola. It does in fact, however, have the same end behavior as a quadratic because it's an even function. Up and to the left, up and to the right. Okay. So if we go back to our problem, again looking at these 5 values, we'll go back and hit second and then graph. This particular menu is fantastic because it portrays the xy values. And as you can see, negative 2 gives us 35, negative 1, negative 2, 0, negative 5, 1, negative 4, 2, 19. And we can see that as they provided for us on the xy table. So let's go ahead and take a look. The graph is in fact the same graph. The changes in sign indicate that there are zeros between negative 2 and x equals negative 1. So negative 2 and negative 1, and between 1 and 2. And let me point out that sign change, particularly with the y value sign change, as we see the difference in the two values here. One is positive and one is negative. And the difference between these two y values, negative and positive. In other words, when we look at the graph, we can pinpoint this point and this point as two zeros, or x-intercepts. But as it turns out, because negative 2 gives us a positive value, positive 35 somewhere up here, and because negative 1 gives us a negative value down technically here at negative 2, this point right here, which we don't technically know, we do know that it at least falls between a positive y value and a negative y value. So that value is sandwiched in between a positive and a negative. The actual y coordinate of that point is 0. Same with this particular point. It is also 0. Speaking of values changing, so plugging in a 1 gives us negative 4, so that's that particular point. plugging in a 2 gives us positive 19. So that's way up here. So again, this particular point, again, we don't know the x-coordinate, but we do know that it's sandwiched in between y values that are negative and y values that are positive. Next set of problems here. So exercises. Graph each function by making a table of values. Determine the values of x between which each real zero is located. So we've got ourselves a cubic, x to the third minus 2x squared plus 1. Let's go ahead and make ourselves an xy table. Now, I will say that when making an xy table on your own, without the assistance of a graphing calculator, it does become a bit daunting to decipher what values are going to work for you. So what I'm going to go ahead and do, I'm going to use the graphing calculator to help us out, typing in our function, x cubed minus 2x squared plus 1. So I'm going to go ahead and clear this. X to the third minus 2x squared, and then again plus 1. Okay, I'm still going to hit zoom 6. I like to get in the habit of hitting that particular button. And here is our cubic. Okay. So, as it turns out, we have a pretty typical looking cubic function. It's odd. In other words, the end behavior goes down and to the left, up and to the right. It is a positive odd function, as we discussed in the last section. Therefore, it does in fact have that end behavior. Now, as far as these zeros, it does appear that there are 3 zeros. Let's go ahead and do what we did in the last problem. On this one, we'll go ahead and hit second graph again. And there you go. Here are some values to interpret. Negative 2, negative 1, 0, 1, and 2, if we so choose again. Or maybe we scroll up a little bit, see how the rest of these values kind of interact here. It looks like we might actually be fine with the same 5 values. So let's go ahead and write down negative 2, negative 15. Again, negative 1, negative 2. I'll just write 0, 1, and 2. And finishing these values off, we can see then 0, 1, and 1, 0. Okay. And 2, 1. Alright. So these 5 values should be pretty nice as far as getting the graph down. So negative 2, negative 15 does in fact go off the graph. So we'll plot it somewhere down here. Negative 1, negative 2, 0, 1, 1, 0, and then 2, 1. Okay, so we can go ahead and start the curve. I'm going to make sure that my graph, yes, it does go up. Stop there at 0, 1, come down below the x-axis here, and then back up again. And it has to, because the end behavior, as we've discussed, speaks to that. Okay, so there's my cubic. Draw my arrows at the ends. So again, we've graphed our function, we've got our table of values. 5 points is perfectly good when it comes to graphing a function quite like this. It does also, though, say determine the values of x between which each real zero is located. Okay, so it appears that in just looking at our values, between negative 2, negative 2 here, negative 1 there, 0, 1, and 2, but between technically negative 1 and 0, we've got this 0. We've also got this 0, which is right at a nice value, a nice integer value that we've already come up with. And then we've got this value right here. Okay, so we have 3 zeros. The question again, determine the values of x between which each real zero is located. So for this first value to the far left, it appears that that point is between -1 and 0. To confirm that, we can actually look at the y value of this ordered pair, which is -2, and the y value of this ordered pair, which is 1. Because one point has a y-coordinate that's negative, and another point, the second point, has a y-coordinate that is positive, we can say that this 0, again with a y-coordinate of 0, has an x-coordinate that falls between 0 and -1. So, we can define that then as follows. Between 0 and -1. Okay, so that's just one of the zeros. Technically there are 3 zeros, so we'll do the same thing for all. Well, as it turns out, we can definitively say that the second 0 is at 1, 0. So there's no question as to what the x-coordinate is there. We know what it is. So we don't need to say what two values it falls between. The third 0, on the other hand, well, the question here that we need to consider is that value right there, is it less than 2? Well, the answer to that question is yes, it has to be less than 2. And is it greater than 1? Well, yes, it has to be greater than 1. So it is in fact between 1 and 2. Okay, I'm going to go to the graph to prove this. And what I'm going to go ahead and do is I look at this right here, technically, this point. It's something comma 0. Looks like 1 point something. To definitively prove what that value is, let's go ahead and hit second, trace. I'm going to hit option 2 for the 0 feature. And the process works like this. We scroll to the right. I'm going to stop it probably somewhere here. Noting that my y value is negative, hit enter. So that's my left bound. Scroll to the right. Noting that my y value is positive, here, hit enter. So we're going to go ahead now and hit enter on guess, which should give us the actual 0 at 1.618. Now, that number, as you can all hopefully see here, that number is in fact between 1 and 2. And that's exactly how I want you to write this last answer. Between 1 and 2. Okay. Let's go ahead and take a look at number 3. So number 3, we're going to go ahead and create another XY table, and we're going to go ahead and type it into the graphing calculator and see what values are going to work best here. So, y equals, let's go ahead and clear this, negative x to the 4th plus 2x squared minus 1. Alright, zoom 6. And here is your quartic. It's called a quartic because the exponent is 4. And as you can see here, the graph goes up, and then back down again. So the end behavior, if we were to go ahead and reflect back on the last section, as x goes to the left, y goes down to negative infinity. As x goes to the right, y goes down to negative infinity. Okay. And of course, we've got ourselves 2 zeros that we will have to identify, at least the exact points, or the points that they fall between, or values I should say they fall between. Let's go ahead. Before we do that, let's hit second, graph, and then taking a look here at some values, -2, -1, 0, 1, and 2. That might be enough. go back to my graph and see if I can use those values.